Okay, naming organic compounds. We're going to follow the IUPAC, or the International Union of Pure and Applied Chemistry, for their system of nomenclature. It's an international, not run by any government, organization that's recognized as the world authority on how to name things. Okay. When naming organic compounds, the first rule is to identify the longest chain of carbon atoms. The longest chain of the carbon atoms gives the stem or the root as the name. Okay. You need to memorize these for the number of carbons in the longest chain. We'll get to alkanes, alkenes, alkynes in a little bit, but remember alkane is a saturated hydrocarbon. Hydrocarbon's one word, I can't fit it. What that means is saturated means that it has only single bonds in the molecule, and then hydrocarbon is a compound made up of carbon and hydrogen. So all alkanes are saturated hydrocarbons. Okay, the longest chain of carbon atoms in any organic compound is going to have these as the stem or the root of the name. And again, you need to memorize those. If you're naming a molecule and it has two chains of equal lengths, you've got to pick the one with more branch points. Okay. You're going to number those carbons in the longest chain. And how you want to number them is so that the position or number is going to be the smallest number in order of this following priority. Okay. First thing, and I don't think we're really going to name that many things that are all this complex, but okay, the thing that you're naming the compound after, meaning a double bond if it's alkane comes first, or the OH group if it's an alcohol, you want to minimize those numbers. So for multiple double bonds, those are the alkenes. Okay. And you're going to follow that root with diene, triene, tetraene, depending on the number of double bonds. If it only has one double bond, the ending will just be ene, an ene. Okay. If there's two in the molecule, it's going to be a diene. If there's three double bonds, it's a triene. Okay. The second thing to look at is to minimize the number of the first branch or the substituent group. Third thing, if both ends have the same first branching number, then you number the chain to minimize the position of the second branch, and then the third, and so on. I really don't think we're going to get to the point where we have to look at this, but if we do, if you still have a tiebreaker that's needed, you're going to minimize the number of the substantia group that comes in alphabetically, because remember, we name things, or we'll see that we name things according to functional groups, and they go alphabetical. An additional note is that in cyclic and aromatic, meaning benzene derivatives, there is no number needed if there is only one substituent. And we will look at that. Remember that benzene is that ring of 6 carbons, okay, with a resonance structure, meaning a double bond every other, and you can draw this to represent both resonance structures. Don't let this all, kind of makes your head spin a little bit. We're going to do plenty of examples. The examples should make this all pretty clear. Okay. So let's look at functional groups. What we're going to look at here is the series, okay, and that just means that the it's as you go up in molecular weight as you add carbons. We're going to look at different functional groups, what their suffix is, meaning what would go on that root or stem, that meth, eth, prop, but. Okay, and then an example of a compound pretty much sticking to something that has 3 carbons in it, or this prop. Okay. So, functional group alkane, there is really no functional group. The suffix is just an, and then you have propane. When we get into the -ene, again, double bond somewhere in the molecule. The suffix then will be -ene. Here I have 3 carbons with a double bond and it's propene. Why don't I need a number here telling me where that double bond is? That's something you should think about. The alkyne series, there's a triple bond. Suffix is a YNE. Again, our example with the 3 is propyne. Again, why don't I need a number telling me where this would be located? If I numbered these carbons, this would be 1, 2, 3. Okay, starting with the carbon closest to that triple bond. The alcohol functional group, OH, ends in an OANOL, again for propanol. That tells us it's an alcohol. That tells us there's an OH grouping. Functional group, the nitrile functional group, is a carbon with a triple bonded to a nitrogen. This is the suffix that we're going to see. Looking at, again, that 3 carbon. That's the name. Aldehyde. These are always at the end of a molecule. Okay, carbon double bonded to an O, single bond to an H, ANAL, propanal, C2H5CHO. Take note of how this is written in the condensed formula. Seeing this, chemists know that that's the aldehyde group. A ketone, this R stands for some chain, some carbon chain. R prime can be a different carbon chain. The ending ANONE, propanone. Again, take note of how this is written. Okay, here is really what the ketone group looks like. These would be the 2 R's, R and R prime. They happen to be the same in this example, but they don't necessarily need to be. Carboxylic acid, this one again only comes at the end of a molecule. If you notice, it can't continue the chain. This can't be in the middle because this carbon has 4 bonds. The suffix is going to be enoic acid. Formula, again, when a chemist sees COOH, they know it's a carboxylic group. Propionic acid, this is the only one that's like 2 words. An amine group, NH2 at the end. Formula and the name for the 3 carbon. Thing to know about the amine functional group, this NH2, sometimes these H's can be replaced with other alkyl groups. Okay, a chain of carbon. Right? Giving rise to secondary and tertiary amines. These are named using the N to show the position of the substituents. Okay. So for here, propanamine, okay, with just H's connected to the H to the N. You notice here that one H has been replaced by a methyl group. This would be N-methylpropanamine. 2 N's if both of these H's have been replaced. Since both, we have to say di. That tells people there's 2 methyl groups, propanamine. Amides or amides, you can say it either way. Again, this needs to be at the end of a molecule, as did the amines. and the name with Amide, propanamide formula. Keep note, CO means that's C double bonded O, and then the NH2, and you could use the N and N for naming them if these H's get replaced by other alkyl groups. Okay. Things to take note of is this use of primary, secondary, and tertiary. This primary amide means it's connected to two H's. When you go secondary, it is only connected to one H with two carbons. And then a tertiary, if you notice, this nitrogen is connected to three carbons that makes it tertiary amide. And we use these terms also with carbons somewhere in the chain, depending on what those carbons are bonded to. Esters. Oops. Functional group for an ester, NO8. Here is the formula. The COO tells us that it's a C double bonded to an O, then single bonded to another oxygen, and then there's an alkyl group. This group that kind of takes the place of the carboxylic acid H, if you notice that. This looks very similar to a carboxylic acid, except this is not an H, it's a group. That group name is what goes before the three-chain ester. So whatever this group is that kind of takes the place of that H on a carboxylic group is the prefix with an il, and then the three-chain name for the ester goes at the end. And again, that's just what I said. All right, so organic salts, where the alkyl group of the alcohol has replaced the hydrogen of the carboxylic acid. We'll see this reaction later in this unit, but just remember to name them. The alkyl group, meaning the group that's replaced that H, goes first, followed by the name of the acid anion, which is this. Okay, so methylpropanoate. So, important in organic compounds is to indicate the position of functional groups within that group. I think what we're going to do is, since we've covered kind of all of the functional groups, I'm going to continue on another screencast with the actual putting all of those functional groups together.